Okay.
Okay, so recording now, and the screen. Wait a sec. Change present. All right.
Okay. Can you
See your
see?
screen now?
Yeah. Is it okay? Yeah.
Yeah.
So maybe I will start with the Excel sheet. I think it will be easier to figure what we are talking about. So here is just a result sheet, nothing to do with the code or the input topology. You can see I've simulated this very simple network. It's a point-to-point from A1 to A13. You have SSMF fiber with increasing incremental distances and incremental span losses, of course. And one possibility is you set the same power in all span. So that's what is called a simulation 3. You could do a simulation where you set the same power. So this is the power difference between the span. It's an arbitrary reference. And here to 0, it means everyone the same. And at the same time, you know that you can input a channel power in the spectral information, and you can power sweep this spectral information power. This is what you see here. So it means for simulation 3, which is the simplest, I can sweep from -1 to +2.5 dBm in all the span with the same power setting. So -1 in every span, then -0.5 in every span, etc., up to 2.5 dBm. Okay, is it completely clear? Yeah, it's very simple. Yeah.
So what does simulation 1 or 2 then means? Because so you said here the calculated span, let's say -3 from A1 to A2. So
I'm
that's
coming to it.
Yeah. Okay. Sorry.
Just so that at least the first the starting point is clear. Yeah. The hypothesis and the starting point is clear. Okay.
So let me try to ask again the question. So
of course,
since you put here the value 0 on column H, so that means let's say the starting point is equivalent to what we would see here on simulation 1. Basically, it would start at -3, and then plus -1 plus 2.5.
forget about simulation 1 and 2 for now.
Okay, but forget it.
So it means that in the first span, I'm going to launch -1 dBm in a first sweep. So it's different simulation here. A power sweep. That's why I don't want to speak of simulation number yet.
Yeah.
Because the power sweep in itself is I don't know 5 different, maybe 7 different simulation already. It means it's going to launch. Let me do it. That's the power sweep. Okay. I'm running. This is what it says. I should have started with that. So it says let it complete. It says it has tried to optimize the power in each span and considering the settings configured in the equipment configuration JSON, and we are not discussing it how it is done yet.
Yeah.
It put the same power, the same setting power in all span. So these are my all my span, A12, A13, A1, A2, etc. So the 14 span, same power setting. And now it's going to propagate across those 13 span -1 dBm. Which means it's going to have -1 dBm in every span because there is no power difference between the span. And it's telling that with this setting of power, the resulting SNR is 11.5 dBm. And then, since it's a power sweep from -1 to 2.5, it goes to -0.5 dBm. And now it's running the simulation for -0.5 dBm, meaning that I'm going to launch -0.5 dBm in every span 1, span 2, span 3, etc. And now you get the SNR. So you can plot, this is the yellow curve, you can plot the SNR as a function of the power that is launched when all the power setting is the same in all span. Okay? And this is what we used to have up to now. This is the simulation because in automatic design, it just set the same power setting in all span. Of course, if you do a manual design where you put your own gain, your own amplifiers, it's possible to have different power setting.
So when you say the same power setting, it's basically the loss of the previous span, right?
It's the channel power, it's the launch power in the span. It's not the loss. It's regardless of the loss of the previous span, you launch same power in every span.
Okay.
Yeah?
Yes.
And now you could say, okay, and I'm going to show in the presentation, it's a very sound scientific thing. You could say on small span, I don't want to send as much power as on long span. For very long span, you know that you may want to use Raman amplification or you want to use booster amplifier with more power, because the optimum setting between ASA noise and nonlinear noise is moved toward the ASA noise contribution, because on a long span, the nonlinear contribution is almost the same as far as the fiber is concerned, whereas the loss make it that the ASA noise contribution is higher. So you need to adjust your optimum to have a bit more nonlinear effect by increasing the power so that you reduce the ASA noise. So that's where what you really want to do is have a power difference in every span. So for example, in simulation 2, is the full flavor of this power difference. You can show in the GN model, if you derive a very simple equation of the GN model, not the complex about the INL setting, just once you have calculated your nonlinear contribution, if you derive the SNR versus the channel power, we can show that the optimum power setting is dependent upon the span loss and the noise figure of the following amplifier. Let's focus on the span loss for now, which means that you could want to set this power difference between the sets. So what it says here, it's a power difference, and it will be relative to the power sweep. I want 3 dB more in the longest span, and I want 3 dB less in the shortest span. 3 dB less or 3 dB more than what? But 3 dB more than the power setting that you power sweep. Remember, in the input of your simulation, you always input the power per channel. So you can still do that. It's still completely transparent. But this power, it means then for -3 that the power that is launched in the first span, in the first sweep, is going to be -4 dBm, -1, -3, -4 dBm. And in the last span, it's going to be +2 dBm. And in the last sweep, it's going to be -0.5 dBm and 5.5 dBm. Yes? Is that clear?
Yeah.
And you can still find the optimum. And this is the blue, the red curve. This time it's the red curve. And in a sense, you could think, okay, it's the same. I'm still going to do a power sweep. I still have the same amplifiers. I should have the same result, more or less, or no? You don't, because indeed, you have locally optimized the power setting, and which means that this simulation is better than the simulation 3. And when you do the power switch, you can see that the optimum value is about half dB better than on the yellow curve, which was for the same power for everyone. So it means that by actually optimizing the power per span, so doing a better design, basically, you actually improve the system, the performance of your system. And and one possibility also is to say, okay, I don't want this such a differentiation. Maybe I want less differentiation. I want something simpler, and this is the parameters that I will show. I just want a granularity of 3 dB, for example. That's what it says here. So the input of the power range is to say, okay, I want an excursion of -3 dB, +3 dB, and a granularity of 3 dB. In the previous simulation, the simulation 2, I have asked the same, but with a granularity of 0.1 dB. But what we see is that even with a granularity of 3 dB, at the end of the day, it's pretty much the same performance. It's the blue curve that you see here. Okay, but here it's already quite an improvement. So what I can show now is the configuration of the JSON. I can show also maybe quickly the slides just for the basis. So what we do is here. So we are saying that the power setting when we derive some of the GN model equation, we say the power, the optimum power is the third, the cubic of the power is dependent on the noise figure and the span loss. So it means that the slope is 1/3. This is what you see. What you see here in the dependency between those two spans, 100 and 110, there will be 2.2 dB difference divided by 3. It makes about the difference of 0.7 that you see here between the two power settings. And what you, so the first simulation where everything is equal is like this. And what we are doing now is a power sweep with this range of differentiation. Okay? Is it making sense so far?
Yeah.
Vittorio, what do you think?
Yeah. Sorry, I was trying to find the muting button. Yeah, it's really interesting as we already discussed. So I guess.
Yeah. So here I was happy to see it work on the simulation. For me, it's the first time I see the result, the actual quantitative result. I knew it was better, but I didn't picture what was the gain exactly. So that in this example, for example, it's something like 0.5 dB. Makes me think, by the way, that if we want to further improve the algorithm by taking into account the noise figure difference, the gain might be very small, maybe not worth it. Don't know what you think.
So your question is about taking account or not the noise figure versus frequency, you mean?
In the power, in this optimization, you want to set the power difference per span as a function of the fiber type, of course, and also a function of the noise figure of the following amplifier, because it has an influence as well on the ASA noise contribution. So far, I have not taken into account the noise figure difference that could be between the different spans, you see? But since the gain is very small.
Why you think to get different noise figure? Because of the behavior of the amplifiers, just take into account
different noise figure models, different gain, different losses. For example, so I can show you after. There are differences in the noise figure when we put the variables on. But I think the gain would be very small, and it's a lot of effort. So I will see, but maybe it's not worth it.
I don't think so. Perhaps you can get a big difference if you have completely different amplifier, but if they are more or less the same, so you don't expect to get such a big difference, of course.
You could get a difference, I think, if we start mixing Raman and EDFA.
This is exactly what I was thinking about. Very different, if you use hybrid amplification for Raman, whatever, so the different noise figure will be several dBs. Otherwise, you're in terms of within the range of fraction of dB, I guess.
Yeah. So let's put the picture.
The effect, the leveraging is reduced by the 1/3 one in front of everything, so it's mitigated the effect of the noise figure on the actual optimal power as because of the physical effect. And so only when you have a considerable difference in noise figure, you experience a big difference in the optimal power and then the consequent capacity advantage. So I agree that if we keep a line system uniform in terms of amplification method, so I don't see any big advantage in what you are mentioning as big effort. If we mix, it's I don't know. At this point, it's a matter of discussion how operator deploy their lines. So it's not my field.
Okay. Yes, we could mix, but I think we can. It means that we can wait to have the Raman module, and as soon as we get the Raman module, we can improve that.
Yeah. At that point, we will. Okay, I don't want to go into many details, but of course, with Raman amplification, we will have also some variation of the nonlinear effect and some tilting of the NLI. So at that point, we will have to take into account also variation with frequency, and so the approach will be a little bit more complex. But okay, we will see it. So far, I guess it's enough. It's a good work you have done. So.
Okay. And for the setting, then it's fairly simple for now. So what it says, I have added in the span definition, you can set the range you want this variation to occur. So for example, if you still want to keep the same power in every span, you don't want this kind of optimization, so-called optimization. It's not really an optimization. It's not complete. It's just a halfway, so that you keep knowing what is going on. It's not an hidden optimization that does something and you don't know what is going on. That's very important. And if you want to deactivate it, you just say that the minimum excursion, the maximum excursion is to be 0. Otherwise, all you have to do, for example, you allow this much excursion and you allow the step. I think a typical step on the power differences you want to have in a for span is 0.5 dB or maybe 1 dB. And I know even some system, it's 3 dB. They just have a high power amplifier, a mid power amplifier, and a low power amplifier, and that's it. And then you still have the power sweep, which is here. And at the same time, you can set the power sweep. So, for example, if you don't want to power sweep, you just put that to 0. And then you have the classical simulation where we can see actually, you see the difference in the noise figure. So we are about 6 dB here for the long span. And for the small span, it can be up to 9 dB. You can see on the small span as well, there is some padding. So that's a new feature as well that has been implemented because the span, oh, sorry, that's for the RODM, sorry. It's because we are using the standard fixed gain, which is a new feature as well. So it's picking the best noise figure. So it's why here it shows to take the fixed gain for the RODM loss, because 20 dB loss is not far from the 20 dB fixed gain setting. And for the fiber, you see here you have this padding, so that the total loss is 10 dB, because it's a short length of fiber. And we have asked for a padding of 10 dB in the configuration, which is here. Okay. So at a glance, these are all the new features. Okay. I think I can. So, and it's in power mode. So you still have the gain mode. So the optimization, the delta power range is not going to work in gain mode, for example, if I rerun the simulation. So now it's not telling me at the beginning what is the power difference between span. It doesn't do it. And we could check the output power of all amplifiers is the same. 18.8 for all span. Okay. Whereas before we had some 22 dBm for long span and 18.8 for the middle span. and maybe less 15.8 for the short span. Okay. So what do you think of the parameterization? Is it simple enough? You think it's something that is understandable and sufficiently?
Yeah, I'm wondering, sooner or later we will probably need to write a kind of a documentation for that.
Yeah, for sure.
Yeah, I mean, Esther did a very good job in documenting the Excel part. So
yeah.
Yes, about the list of parameters. So I guess they are wide. It's wide. It's wide enough. So you can parameterize everything you need to do. From my point of view.
Yeah.
I of course agree with Gerd that at some point some documentation will be.
Okay.
Yeah, I'm trying to imagine if, let's say, somebody who was not involved in our working group, but interested, let's say, gets in a project and would like to understand what works and how it can be used. So there should be an easy way for him to get into it. So far, we have our examples, which are okay, but without additional explanation, it's even there. You know, it takes time to figure out what exactly it means.
Yes, completely agree.
Anyway,
yes,
yeah. We first need to do the work, and then we can also work a little bit on documentation. So, thank you very much, Jean-Luc. It was really interesting.
Welcome.
All right. If there are no more questions to Jean-Luc, I would then again change the presenter. And oops. All right. Go to the next page. The Raman prototype. I saw Alessio is not in. Probably he's already in vacation.
No, he's working on finalizing the module we are planning to upload by tomorrow, as the timeline that was included in the plan for this activity. So by tomorrow we will upload the Raman server, that is the mandatory module that we need to implement in order to apply the modeling, including Raman. Okay. And so he asked me to be able. Okay.
Okay. All right. So then we should have the first code by end of the week. About the development branch, James.
So last week we had set a goal for ourselves to do a tagged master release. We put that off until an incoming PR from Jean-Luc. I haven't seen Jean-Luc if that's ready to go yet, but if that's ready to go, then I'll review it and we'll include some of that additional feature work. We decided to put off the master release until we had these additional features in, just because we felt like these features, the decision we made on Tuesday was that we felt these features would be attractive enough to users that it would be nice to have them in the next master release. So once Jean-Luc's feature PR is ready to go, we'll get that pushed. Okay, fantastic. So I'll review it. I noticed in the first iteration a couple of small things that we might fix, but we'll get that ready to go. We'll get the additional testing in place. And once we have that master release out with some of the additional testing in place, we may now consider moving into a new regime for how we develop the software. Previously, the regime was kind of, okay, we're just going to get features in and testing is going to be a little bit less important so that we can focus on features. Now that we have sufficient testing in place, continuous integration in place, the new regime may be one of, okay, the responsibility of a code author is to include tests in their work and to make sure the tests pass. But if something breaks and it wasn't covered by a test, the responsibility of that is the author of the functionality, the original functionality, for not writing a test in place. So we'll move to a model where, you know, if you're adding new functionality to the project, you're responsible for creating the tests, which other people will check. But other people aren't necessarily responsible for writing tests for your work. And so that'll help us speed up development. And I think it will be a little bit easier for us to onboard new contributors because they won't have to worry about the masses of everything that's already been written. They can focus on just the one feature they want to work on and have confidence that the tests in place cover all of the stuff that they may need to take some time to get up to speed with. In addition to that, so subject to that, we may do a couple of rounds of refactoring afterwards. And probably on the Tuesday call, Jean-Luc will discuss this new feature work that you presented now and the refactoring, how we want to balance those, what the right balance of that would be. So that's the state of the software as it stands today. And we're kind of moving in the same direction that we were moving in before.
So
James, just on the test.
Also, Gert, I think there was one other thing is, there was one additional documentation bug that was brought up. That'll also get addressed, Gert. I didn't have a chance to comment on the GitHub issue, but a couple of people might have noticed the repo changed names, and so it caused the documentation to be out of date. Yeah,
I think there are a few minor things to be fixed, but I'm not worried. So let's say in terms of time frame, I understand that we probably need say another week or so until the new master branch will get out. Is that kind of your plan, James?
I think that's reasonable. What I would say is any feature work that's still pending, anybody who's working on some features, don't wait for the master branch to be done. Just keep doing your work. When you're ready, submit a PR. It's good to have that because it'll start a discussion about it. If the PR needs some merging, then on the Tuesday call or over email, we can decide how to do that merging, whether we do the merging on my side or do it on the author side. But don't let this hold up any of your work. If you're working on features, just continue working and we can sort out the merging. If you've structured the commits well, we can sort out the merging pretty easily.
All right. So look, you had another question?
Yes, comment on the test. So yes, we work on the test, but don't expect the test to cover everything. It's still a complex scientific calculation, and unitary tests. For now, we have been doing unitary tests, and it cannot complete. It's difficult to test the whole thing. So
absolutely.
we would need to move to functional test, and this is hard work that needs to be planned.
Absolutely. And so as we move into this new regime, obviously it's not the case that we're going to be very strict about it. We do have to, as Jean-Luc said, we do have to keep in mind that some of the tests that are missing aren't missing because of negligence. They're missing just because they're very difficult. And so I agree, Jean-Luc, we'll have to be delicate and use good judgment. But I think the general perspective is what we want to shift.
Yeah, but it was more comment on the thing that we can catch everything by test. I don't know. It might be a bit ambitious. I'm not sure it's possible to catch everything just by test. There will still be bugs that can only be discovered because we see that something wrong is going on. But yeah.
Okay. Let's do our best.
Yeah.
Okay. So then let me go to the final page. Then there are a few pending actions. So one was for the chairs to set up a leadership session at ECOG. So it depends a little bit on the timing we have on Wednesday. So if indeed we meet on Wednesday morning, we could set up a leadership session in the afternoon. Otherwise, it would probably go to Thursday. But again, let's wait for Diego to come up with a schedule, and then we see how we can squeeze it in. Then Vittorio wanted to solicit some input on the Raman questionnaire. Do you need more time, or what is the status, Vittorio, on the questionnaire itself?
Actually, I didn't get any. I was waiting for a feedback for a member that volunteered to send me data sheets in order to understand what is typically available, but I didn't receive it. Perhaps he's already in vacation. Or,
yeah.
I don't know.
Okay, maybe you can
in the call as well.
Yeah, if you can send a reminder email. Maybe just forgot it before vacation. Okay, thank you. Okay, Diego wanted to send out the plan for the ACOG tip session. I understand that it's probably going to be sent out next week. Is that correct? Diego? Still on mute? Well,
sorry guys. My mute button wasn't working.
Yeah.
Yes, you were ECOG update. I will. Yeah. So as I was mentioning before, I will send reminders today, and we'll have the updated agenda for hopefully. So I'm meeting with tomorrow.
Okay.
So by early next week, either Monday, Tuesday, we'll have.
Okay. Speakers. So if there are speakers here, Vittorio was one of them, and Gabriele, I think, was the second one. Please send your details to Diego. Also, if somebody here on the call who wants to speak, also James, please send all your details to Diego so that he can put you on the list and create the agenda. And I think this one moved out. So we said yet another week. So let me put here August 10 as a target.
Yes. Okay.
All right.
Sounds good.
I think we don't have any new actions, so I will keep them. And so, yeah, talk to you then in 3 weeks from now.
Okay. Well, have a good birthday. You're taking some time off, right?
Yeah, 2 weeks. Yeah.
Nice. Okay. Well, enjoy your holidays, your vacation.
Okay. Thank you, guys.
Okay. Thank you.
Bye.
Bye-bye.
Thank you.
Ciao.
Bye bye.
Bye.
Ciao.